Question number 19, exercise 6.5, class 12th. Show that of all the right angles inscribed in the given fixed circle, the square has the maximum area. Means that in triangles, in circles, right angles make the right angles, and the square right angles is the maximum area that is show. So solution start. Let a right angle of length L and width B inscribed in the given circle of radius A. Then the diagonal pass through the center is the length of 2 centimeter. That the circle, and that is the right angle, and the diagonal is 2A because A is radius of circle and this is 2A, and B is width and L is length. So now by applying the Pythagoras theorem in the triangles, so bracket of 2A whole square is equal to L square plus B square. So this relations to find the B value in terms of L. So B square is equal to 4A square minus L square. B is equal to root of 4A square minus L square. Area of right angle A is equal to length into width. So L length into width is B is equal to root of 4A square minus L square. So into root of 4A square minus L square. Differentiate with respect to L. So here the differentiation of U and V formula is used. So dA upon dL is equal to here root of 4A square minus L square take constant, and the differentiation of L is 1. So root of 4A square minus L square plus here L is constant, and the root of 4A square minus L square differentiation is 1 upon 2 root of 4A square minus L square. Inside the root differentiation for A square is constant, and for A square is constant, so differentiation is 0, and minus of L square differentiation is minus of 2L because minus, and L square differentiation is 2L, so minus 2L. So 2 should cancel, and L minus L to L square is L square minus of L square, so it's equal to root of 4A square minus L square minus of L square upon root of 4A square minus L square. Here take root of 4A square minus L square is LCM. So this multiply to this, so this is often, so 4A square minus L square minus of L square in numerator, so is 4A square minus of 2L square upon root of 4A square minus L square. For find the value of L, so here condition is apply. If dA upon dL is equal to 0, then 4A square minus 2L square upon root of 4A square minus L square is equal to 0. So this is transferred to this side, and 4A square is equal to 2L square. So L is equal to, so 2 divided to 4 is 2. So 2A square, so L is equal to root of 2A square, so is equal to root 2A. And dA upon dL function is again differentiate with respect to L. So d2A upon dL square is equal to here differentiation of U upon V formula is used. So first V is as it is root of 4A square minus L square, and U differentiation for A square is constant, so it's 0, and minus of 2L square differentiation is minus of 4L plus 2 is constant. L square differentiation is 2. L square differentiation is 2L, so is minus of 4L minus V U is as it is, so bracket of 4A square minus 2L square, and differentiation of root 4A square minus L square, so 1 upon root of 2 root of 4A square minus L square, and inside the bracket. So for a is constant, so differentiation is 0, and minus of 2l square differentiation is minus of 2l, so minus of 2l upon v square is, so root of 4a square minus l square is whole square is 4a square minus of l square. Here in numerator, I'll take here 2 to cancel, and take the LCM is root of 4a square minus l square. So this is in multiplied to denominator. So bracket of 4a square minus l square power of 3 by 2, and this multiplied to this, so is root of 4a square minus l square multiplied to root of 4a square minus l square, so is equal to bracket of 4 square minus l square, and minus of 4l is as it is, and here minus to minus plus, so l bracket of 4a square minus of 2l square minus 4l multiplied to inside the bracket, and l this bracket to multiply inside, so minus of 16a square l plus 4l cube plus 4a l is 4a square l minus of 2l cube. So here remaining is equal to minus of 12a square l plus 2l cube upon bracket of 4a square minus of l square power of 3 by 2. So here minus of 12 is take common, so is equal to minus of 12 bracket of 6a square minus l square upon bracket of 4a square minus l square power of 3 by 2. So here check the maximum condition at l is equal to, because only l value is find out, l is equal to root 2. So at l is equal to root 2a, then d2a upon dl square is equal to, so put l value is root 2a in d2a upon dl square, so minus of 2 bracket of root 2a bracket of 6a square minus of l square values put here root 2a, so here you make is 2a square upon bracket of 4a square minus l square is make 2a square, so bracket whole power of 3 by 2, so is equal to, this is minus of 2 root 2a, and this is 6a square minus 2a square is 4a square upon in denominator is 4a square minus 2a square is remaining is 2a square power of 3 by 2. So this is equal to minus of 8 root 2 a cube upon 2 root 2 a cube. So this divided to this, so remaining is equal to minus 4, that value is less than 0. That is the maximum value condition. Therefore area is maximum at l is equal to root 2a, and b value, so b value put l value in b is equal to root of 4a square minus l square, so b is equal to root of 4a square minus bracket of root 2a whole square, so is equal to root 2a, means l and b value is same, that is the square. Hence area is maximum all triangles. In fixed circle the square area is maximum, that is the solution.